Okay, guys, can you guys hear me?
Yes.
You guys hear me? Okay, perfect. All right, so let's get started. So welcome to our knowledge-based lecture. This is like pretty much as a comparison to our bootcamp. Now you're actually entering our knowledge-based lecture. The difference between our bootcamp and knowledge-based lecture is that our bootcamp is going to be more giving you a high-level introduction. For each lecture, we have like one topic. Another lecture, we're going to go to another topic, so on and so forth. Okay, by the way, student got a question. He can't hear me. So can you guys hear me? Can you guys hear me?
Yeah.
Okay, perfect. Then maybe, yeah, that's going to be your own problem. Can you just try to do you can disconnect and reconnect. Maybe that's going to help you to fix the problem. Disconnect from the audio and then reconnect. Okay. So let's continue. So basically what's going to happen is that in our knowledge-based lecture, you'll be able to basically have more exposure for all the topics. For instance, in our knowledge-based lecture, we're going to be using 10 lectures talking about a specific one topic or two topics. So therefore, it's going to give you more idea, more detailed explanation for certain concepts. So as we comparison, like our bootcamp is going to be more like a snapshot, give you everything within one lecture, while in our knowledge-based lectures, we're going to give you more ideas, every single step, how you're going to evolve for different topics. So this is kind of like a short and brief overview about our lectures. So at this moment, you are actually within our concepts-based lectures, session number 7. In these 10 lectures, we're going to be talking about inequalities and polynomials. These are two very important concepts in the algebra. A lot of students might already have some exposure somewhat to inequalities and polynomials. We're going to be using our 10 lectures to give you guys a very good summary, all the important concepts you need to know for these two topics, and the most classical problems you're kind of like expecting for these two topics. And most important things, I'm going to be teaching you guys some common strategies. Different strategies, what are you going to do as long as you're dealing with all these problems? So let's work out all those things together within these 10 lectures. Hopefully, we're going to give you guys more idea how to deal with all these problems. So before we get started, what we like to do is we like to give you guys some kind of a preview. What are the concepts we're about to show you guys for these 10 lectures? So this is actually outline for our lectures. Like I said, we're going to split our lectures into two parts. Okay, by the way, I think we still got a student. One of the students still got a problem. Hey, Yan, I think you got a problem with your audio. So what's going to happen is that you need to have a audio card connect to your phone or connected to your computer in order to receive the audio. You can either use, you can either use a headset or using like a Bluetooth. Okay, so this is going to able to enable you to access for the audio. Since the other students has no problem, I think our lecture has no problem. It's more like a configuration problem on your side. You can try to disconnect, reconnect, or even change a different computer in order to enable you to access the audio. Okay?
Excuse me, but if he can't connect to the audio, I don't think he can hear you either.
Oh yeah, you're correct. So can somebody do me a favor?
You might want to just type it in chat,
right.
I think.
Because I'm actually doing the lectures. Can somebody do me a favor? Type something into the group chat. So therefore, Yan will be able to access the information I just broadcast. Is it good? Yeah, maybe somebody can do me a favor, type something into the group chat. All right, so let's continue, okay? We'll have to make sure like the majority of students were on the same page. So this is actually an outline of our 10 lectures. So we're gonna be split our lectures into two major parts. One is the inequality, while the other part is polynomial. So talking about the inequality, we're gonna get started talking about some basic inequality related concepts. Like I said, it's the inequality basics. And then moving forward, we're going to talk to one of the most important inequality you're going to see during all kinds of math competition, aka that's the mean inequality. If you go to the North American math competition, you're going to be able to see that pretty much 90% of the inequality-related problems will get involved with the mean inequality. So that being said, mean inequality is the foundation, is the basic. Most of the other complicated flowery inequalities are actually derived from the mean inequality. So therefore, we're going to spend a lot of focus for the mean inequality. And moving forward, we're going to talk something about the Cauchy-Schwarz inequality, which is also a very important prototype of the inequality. From time to time, you will be able to see different kinds of inequality problems that are actually using the combination between the mean inequality and also the Cauchy-Schwarz inequality. All right, and then at least we're going to be talking about our inequality proving strategy. So this is going to be kind of a combination between all those kind of inequalities. For instance, we're going to talk about some comparison methodologies, scaling methodologies, construction methodologies. So by the time that I will be able to show you different ideas how to use the proving strategies we introduced, try to solve all those kind of inequality problems. So inequality is going to be the major part of our lecture because inequality takes a bigger portion in the math competition. And then as long as we're done, we're going to go to the second part, which is the polynomials. I think most of the students, you shouldn't be very unfamiliar with the polynomial because we're actually learning a lot of polynomials from day one. Let's say our linear function, our quadratic equation, right? These are all considered to be a type of polynomial. So again, we're going to get started with the polynomial basics, talking about the basic concepts of the polynomial. And then moving forward, we're going to spend some time talking about two very important concepts. One is the polynomial and its roots. And the other part is the relationship between the polynomial's roots and the coefficient, aka our WECHAT formula. I think you should be familiar with the basic relationship of the WECHAT formula when it is applied in the quadratic equation. Now we're going to try to elaborate a little bit to make it not only applicable for the quadratic, but what about for the third order, fourth order, even the higher order polynomial. So this is going to be considered as a evolving or elaboration for our existing WECHAT formula. And for the last two parts, we're going to talk about the polynomials long division. I think some students keep asking me, how can do a division between two polynomials? How can find out the quotient and also the remainder? We're going to talk about how to do that all together with some kind of applications for different problems. And also, we're going to talk about the polynomial functions as an advanced application of all the polynomial concepts we talked about previously. So this is pretty much a short and brief explanation about the polynomial. So while students got a question, what is a polynomial? We will talk about it when we're getting there. Okay, for now, it's kind of like a forecast. This is a preview. So this one talks about what we will be talking about in our 10 lectures. And then more details will be given when we're getting to each specific lectures. All right, so just keep it a little bit mysterious for now. Now, let's go to our lecture number 1. In today's lecture, we're going to talk about the inequality basics. So, lecture number 1, inequality basics. I think the concepts of the inequality shouldn't be very unfamiliar for most of the students, especially when you go to your elementary school, you already find out how to do comparison between two numbers, which one is bigger, which one is smaller. So the same thing applies when you try to elaborate the concepts into variables or into parameters. So for instance, this page actually lists out some basic concepts of the inequality, which are very familiar, I think are very basic for pretty much everyone. So let's just try to take the time to see how we're going to summarize them all together. Okay, so the first one is fairly easy. The inequality A is greater than B means B is lesser than A. So you can actually swap the two sides of the inequality. And then if we have like A is greater than B, B is greater than C, of course, A will be greater than C, right? So this can be passed on for different expressions. As long as I have an inequality, if I want to add the same number on the two sides of the inequality, for instance, want to add a c, of course, the inequality doesn't change, right? The entire expression is going to hold. If you add something, if you want to subtract something, for sure, easy peasy. Number 4, when I have two inequalities, they have the same direction. When I say same direction means, you see, you have A is greater than B, C is greater than D. Basically, they're facing the same direction, right? So these two inequalities can be added together, right? So the left-hand side, the right-hand side, you add them together, the inequality still hold, which is very understandable, right? Moving forward, if I have an inequality and I want to multiply something on the two sides of the inequality, as long as the number is positive, in our case, C is greater than 0, after you multiply on the two sides, of course, the inequality will hold. Nothing will change, right? However, if the same inequality, you want to multiply a negative value on the two sides of this inequality, the inequality's direction is going to be swapped, right? Which is very understandable. Okay, moving forward, number 6. Like I said, these are very basic concepts. You already know that, I'm pretty sure. But we just like to take this opportunity to summarize everything together so we'll be able to make it more well organized. So number 6, we're going to talk about, let's say I have two inequalities and they're both positive. As long as two inequalities, they're both positive and they're facing the same direction, you can multiply the left-hand side, the right-hand side, and the inequality will still hold, which makes sense, right? Number 7. Number 7 is kind of an elaboration for number 6, because number 6 has like two expressions. You multiply them together, you get a relationship. And number 7 is, what about you have a multiple expressions? You multiply them together, the same property will hold. So if A is greater than B, which is greater than 0, if I want to make n powers on the two sides of this equation, of course, the equation will still, on the two sides of this inequality, of course, the inequality will still be held, right? I think that this is something quite understandable. And as long as you have a power, you have an exponent, automatically, you're going to think about, what about I have an under root, right? So these two operations are always symmetric. As long as you have one, you're going to be think about the other, which makes sense. So that actually gives you the conclusion for number 8. As long as you have A is greater than B, they're both greater than 0. Previously, you can do a power on the two sides. And now I can do under root on the two sides, right? Everything will be exactly the same thing. So here I want to make a very quick explanation why they always want to make something greater than 0. You know, sometimes it does not really have to be greater than 0. For instance, I have like -3. Just want to give you an example. Let's say -3 is lesser than -1. Is that right? In that case, I can do an under cube root -3 is also under cube root -1, right? Lesser than under cube root -1. But because we have this kind of under root thing, we need to do some discussion. Sometimes positive, it is okay. Sometimes negative, you do not even have a definition, right? So let's say you won't be able to see under root -3, right? So that being said, in order to make our life a little bit easier, so that's the reason I just want to keep everything positive. So that being said, not necessarily whenever you put negative, the entire thing collapses. No, but put it as a positive can make our life a lot more straightforward. And actually in our inequality session, especially you go to the Cauchy-Schwarz, you go to the mean inequality, more and more you dig into the inequality world, you're going to find out most of the time we want to have an assumption that everything is positive. Okay, this is only an assumption for convenience, but not a assumption for the for the integrity. Okay, just give you guys a little bit of idea. So don't be surprised if all the discussion we're going to be having will be simply on the negative side or on the positive side. Okay, by the way, a student got a question. Does the square root of negative number exist? You know what? That's a very good question. What about I have under root -1? Is it existing or not? So this is actually will be explained whenever you go to the higher grade. As long as you're talking about the real number solution, no, there's no real number solution for under root 1 because you just can't do that, right? But as long as you go to complex number, you can find out, yes, under root -1 is actually equals to I. So what is I? I will actually use a U. This is kind of a definition for the imaginary numbers, or you can put it as a definition of the complex numbers. So long story short, if you're already asking me in the high school territory, do we have the definition for under root 1? Yes. The high school territory, all the way you go to grade 12, you will be able to see under root -1 equals to I, which is definable. However, for our age, grade 10, roughly grade 9, grade 10, so in our range, no, we'll never talk about under root -1. We only talk about the real numbers. Okay, so hopefully it can give you an explanation. So bear in mind, you can always post your questions into the group chat, or you can just directly unmute yourself and ask me the questions. So our real-time lectures just provide you guys more flexibilities. You can do the real-time Q&A, so that's going to help you to solve the problem on the spot. All right, so let's continue. Okay, let's continue. So let's go to number 9. So again, A is greater than B, which is greater than 0. Again, greater than 0 is more like for our convenience. And then as long as you take the reciprocal on the two sides of this inequality, you'll be able to see the inequality sign is going to be swapped, right? So 1 over A will be lesser than 1 over B, which makes sense, right? 3 is greater than 2, but 1 over 3 is lesser than 1 over 2. Okay, and then let's go to number 10. Number 10 is actually a very important property. And sometimes you see AMC 10, even AMC 12 is going to be using such a property. So let's say I have A is greater than B is greater than 0, and M is also positive. Like I said, we just try to make sure everything is positive. As long as you have B over A, so A is greater than B, so B over A will be lesser than 1, right? Which makes sense. B over A will be lesser than B plus M and A plus M. So that being said, as long as I give you a fraction number, which is lesser than 0, which is lesser than 1, greater than 0, as long as you want to add something for the denominator, for the numerator, the entire expression is going to become bigger, right? So that being said, B over A, as long as you add something for the numerator, for the denominator, they're the same thing, you'll be able to have the new fraction number becomes bigger. So A over B, so B over A will be lesser than such an expression. And then what about you want to subtract something? Exactly the same positive number, you both want to subtract it from the numerator and the denominator, you're going to find your real expression become smaller, right? So B over A will be greater than B minus M over A minus M. Okay, a student got a question, what does the M mean? M just basically a number. It's a given positive number. Nothing really special. Can be 1, 2, 3, 4, 5, whatever. Okay, so this is what is the first expression trying to show us. Okay, let's go to the second expression, which is quite identical as the first expression. But this time I actually take a reciprocal. You see, A is here. A becomes the numerator, while B becomes the denominator. Because the question mentioned A is greater than B, so A over B will be greater than 1, right? So that being said, as long as you have a fraction number greater than 1, and you like to add the same number for the numerator, for the denominator, in our case, the entire fraction number is going to become lesser, right? So this is exactly what is the second expression trying to teach you guys. And then pretty much the same thing we go for the last one. If this time you want to subtract something from the numerator and the denominator, the entire fraction expression is going to become bigger. So you see A over B is lesser than A over M over B over M. All right, a student might say, hey, Alex, there's so many expressions. Do I really have to remember this? Of course not. What you have to remember is just try to bear in mind, as long as you have a fraction number, regardless, greater than 0, lesser than 0, greater than 1, lesser than 1, as long as you want to do some manipulation for the numerator and the denominator together, then you'll be able to change the value of our fraction number. This is actually what I'm trying to say. Because in our mathematics, I never ask you to remember something. This is very low efficiency. The most important thing is you need to remember the concepts and the derivation process, right? As long as you do this one time, then you will be able to remember a fraction number. If you do a little bit manipulation for the numerator, for the denominator, add, subtract, you'll be able to change the value. And then you'll be able to generate an inequality. All right, so this is basically what we try to say for our pretty much the inequality basics, easy peasy, right? We're not talking about anything flowery. But trust me, even though we use some easy peasy concepts, easy peasy formulas, we can generate a lot of interesting problems. In our AMC 8 all the way to 10, whatever, you'll be able to see different kinds of problems that can be elaborated just using this basic concepts. All right? Okay, if all good, let's try to give you some questions, some problem. Just try to use this kind of concepts. Okay, so let's go to the second part, problems. Okay. So before I jump to the problems, I always like to take some opportunity to give you guys a summary. So based on the inequality basics, the basic concepts, what kind of problems you're looking at in the American and Canadian math competition. So there are millions of problems there, right? If I give you the problems one after another, you can never get an end. However, alternatively, what I will be doing is I try to summarize all the problems into different categories and then give you a little bit idea, a little bit representative for each of the category. So what are the problems we're looking at for the inequality basic category? Generally speaking, you're looking at 3 major types of problems. The first type is inequality applications to real problems. Okay, these problems is more like they're gonna give you a scenario, like a real problem, a real case in our real world, and then try to use the inequality to create an inequality and solve the inequality to give the answer. This is more like if I do comparison between equations, right? In our math competition, you always see a real problem. You have to find out the equation, solve the equation, and give the answer. This is pretty much the same thing for the inequality, which makes sense. Later, I'm going to give you guys some real problems, then you will see where I come from. The second part is I can use the inequality to calculate the value of expressions. I can use the inequality to calculate the value of the expressions. Some students will say, hey, Alex, inequality can only give you a range. Let's say A is less than B, right? It's just going to give you a range. Then how come you can calculate a value of an expression, right? Because equation can give you the value. How come inequality can also give you the value? That's a very good question, because as long as you see inequality to determine the value of an expression, most of the time, the question might give you some integer related constraint. What does it mean? For instance, I give you inequality. A is from maybe 3.1 to 4.9, for instance, okay? So everyone knows that if A is a real number, there are infinitely many A's within such a range. Of course, you won't be able to determine the value for A. However, as long as I give you extra information, A is an integer. Of course, you know, within the range, A can only be equals to 4, right? There's no way around. There's only one integer within this range. So that being said, in many of the math competition problems, the question might give you an inequality. and ask you to determine the value of certain expressions, parameters, so on and so forth. No exception. Every single time, they must give you an extra condition that some values must be integer. So that actually gives you another idea. If the question gives you a number is an integer and ask you to determine the value of the number, for instance, the question gives you a is an integer, and then blah, 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 need you to determine the value of a, okay? So generally speaking, our first reaction is let's try to find out the equation, right? And then from the equation, let's say, I don't know, maybe a squared equals to 9 or something, and then try to solve the equation, you'll be able to get a value for a, which is 100% correct. However, after we learn the inequality part, you need to find yourself another solution approach. Sometimes it is impossible to create an equation. Well, alternatively, you can do an inequality. Like I said, in the inequality, you won't be able to determine the value of a, but instead, you might find a range, like I said. You might find a range of a, but a is already constrained to be an integer, then you will be able to list out all the values of a. A can be 3, a can be 4, a can be 5. Okay? 5 or 4. So that being said, this is something very understandable, but it really gives you a direction. As long as the question asks you to determine a value of a number, you can basically go for two approaches. Equation, solve the value right away, or inequality, find out a range, and from the range, determine the integer value of a given number. I'll give you more questions, a real question, and like the real questions, you'll be able to understand the beauty of such approach. And the third approach, the third category you might be seeing for the mass computation is using the inequality to do some guesstimation or estimation. The question is going to give you some inequalities, and you'll be using the inequality relationship between different values A, B, C, D, try to evaluate or guess out a range of certain numbers or some range of certain expressions, so on and so forth. Okay, a quick recap. We're going to be talking about three major categories. The first one is a real application to solve the real problems. Section 2 is we're going to use inequality to determine the value of an expression. And category number 3, we're going to use the inequality to do some guessing, to do some evaluation, so on and so forth. Okay, so this is kind of like a big direction what we're going to be talking about. If all good, let's reuse some real problems to see how you're going to deal with this real problem, the real categories. So let's go to our category number 1. Inequality for some real problems, real application. Okay, let's go for our first problem. Okay, our first problem is a problem that comes from 1996. It's an old problem. It's the American Junior High School Math Exam. That's actually the predecessor of AIME 8. Previously, it gave you the name AJH-SME, because AIME 8 was actually a new name we take it after 2020, after like 2000. Previously, everyone has the American Junior High School Math Exam. Okay, so this is question number 9. Okay, as a common practice, I will give you guys 1 minute, read a problem. And then after you read a problem, let's have some discussion all together. Most important thing is we need to show you guys the thinking process. How do you think for all these problems? So 1 minute, read a problem first. All right, so let's look at a problem altogether. Whenever you read a problem, let's try to highlight the keywords, the buzzword, right? And then we see something can really give us a kind of attention, what we need to focus on when you're reading the problems. So the question says the point A and B, there are 10 units apart, okay? AKA AB equals to 10. Point B and C, there are 4 units apart. C and D, there are 3 units apart. Basically, you know the value of the 3 segments. Point A and D are as close as possible, then what is the number of units between them? So basically, I think this one looks like a geometry problem, right? Looks like a geometry problem. So let's say I have like I don't know, A, B, C, D, right? Something like this. The question talking about 4 different points. The question mentioned that AB equals to 10. BC equals to 4. Okay, BC equals to 4. I'm going to put BC here. Maybe it's closer, right? BC equals to 4. And CD equals to 3. With all those information, the question asks you to determine what's the value for AD. And also, AD should be as close as possible. As close as possible. So it looks like I want to find out the minimum value of AD, right? Which makes sense. The minimum value of AD. Okay. As long as you want to say minimum value, this is more like what? AD will be greater or equal to something, right? Something like this means the minimum value. So that being said, you need to have an inequality, right? If there's no inequality in this problem, of course, there's no minimum value or maximum value. So now my question becomes, I have a bunch of points, 1, 2, 3, 4, 4 points, and I need to create an inequality. Who can tell me? After you seeing such a graph, how can you generate an inequality? What is the basic conditional react for you to generate an inequality? So we're going to talk about conditional react. What kind of theorems, strategies, formulas, whatever, they can help you to generate an inequality? Who can tell me? Who would like to say something? You can always post your answers into the group chat. If I see your answer is correct, I'm going to be asking for you. Who can tell me? Because in order to get started, I need to have an inequality, right? Hopefully from the inequality, you can solve the inequality, get a minimum value. But that's all like step number 2. Step number 1 is I need to create an inequality. The question does not really give me anything about inequality. But with all the concepts we have known so far, how can I create an inequality? Just based on the condition given by the problem. Yeah, if you want to say something, you can just maybe type or unmute yourself. So my question is, how can I create, or can use the word construct, an inequality? Right? This is the question you need to ask for yourself. If there's no inequality, there's no way for me to get started. Is there anything very conspicuous, very intrinsic for inequality? Who can tell me? What kind of condition, what kind of things can give you inequality right away? So maybe I'm gonna ask for Alex.
I was thinking if you could find the relationship between point AB, BC, and CD.
But how can you find out the relationship? What is the most intrinsic thing you can find, you can create as an inequality? But Alex has a very good direction. Then what about the other students?
Teacher, I think the AD at least need to equal or bigger than AB plus BC plus CD.
AB plus BC plus CD. Okay.
Yes.
I think you are in a very good direction, but there's no guarantee because as long as you have a quadrilateral, you have 4 sizes, right? There's no guarantee. Okay, I think so. Let me follow what the Yan, right? What Yan mentioned is he mentioned this: AD must be greater or equal than, right? Something like that. AB.
No,
plus,
I think smaller.
Like smaller. Okay, no problem. Yeah. AB will be small. AD will be smaller than AB plus BC plus DC, right? This is something you say. Okay. I think from a quadrilateral's perspective, there's no guarantee because you can have a very big quadrilateral. You can have something like this. This is going to be bigger or like even bigger, right? Something like that. There's no guarantee that AD must be greater. There's no guarantee that AB must be greater than the other 3, the sum of the other 3 sizes. However, I think Yan gave us a very good direction. If quadrilateral cannot guarantee this, in what kind of shape you can guarantee the relationship?
A 9, a straight 9. Is that right?
Like what? 9?
Oh, is it a triangle?
Yes, it's
Because,
a triangle.
Yeah, because in the triangle, any other 2 sides is always bigger than the other side.
Is it right? That's perfect. That's exactly what we're looking for because there's no guarantee to have a quadrilateral goes like this. However, if I do a quick connection in a triangle, of course, you have the famous triangle inequality, right? In our case, let's say AC, because I already know the value for AD and the BC. Let's try to do AC. AC must be greater or equal than 10 minus 4, lesser or equal than 10 plus 4, right? AC will be lesser, equal to 14, greater or equal to 6, right? In triangles inequality, of course, you have such a relationship. So that being said, for my AC, normally speaking, whenever you have a triangle, you won't be able to see this equal sign, right? Because the third side will be greater than the difference between the 2 or lesser than the sum of the other 2. But however, if you want to degrade the triangle into a segment, you will be able to have this equal sign. Is that right? As long as the equal sign is achieved, the triangle will be degraded into a segment. In our case, I'll give an example. Let's say this is A, this is B. Let's say if C is here, right, on the AB segment, this part is 10, this part is 4, so AC will be equal to 6. But that being said, my triangle ABC will be degraded into a segment ABC. Is that right? Okay, no problem. At least we know there's a range for AC. AC should be greater or equal to 6, lesser or equal to 14. Okay, but the question is not asking me to determine the value for AC. The question asks me to determine the value for AD. So who can tell me what I need to do for the next step? I like to show you guys the thinking process, right? We already used the triangles inequality apply it in the red triangle, we find out a range for AC. But now we're trying to do what? We're trying to determine the value for AD. So what should we do?
I think we should write maybe A minus 3 is smaller or equal to DA, and the DA is also smaller or equal to A plus 3.
Is that right? So that being said means what? Okay, I have already used the triangle inequality in the red triangle. Why don't I use the second time in the green triangle? Is that right? So in my green triangle, what I'll be having is what? Let's say AD. You asked me to determine the value for AD. AD will be greater or equal to DC minus AC, lesser or equal to DC plus AC. Is that right? DC plus AC. So that being said, DC is 3, AC, I just got it, 6, right? So 3 minus 6, I'm going to use 6 minus 3. It doesn't matter. 6 minus 3, lesser or equal to AD, and this is lesser or equal to 3 plus 6. So therefore, 3 is lesser or equal to AD, lesser or equal to 9. Is that right? What does the question ask you to determine? The question asks you to determine what is the minimum value of AD. So of course, the minimum value of AD is here, equals to 3. See? Very straightforward. So the answer of the problem is actually C, is actually B part. You see, such a problem is fairly straightforward. You're not using anything flowery, anything complicated. The only thing you use is the triangles inequality, right? Within the triangle, the third edge will be greater or equal to the other two, and like the difference of the other two, lesser or equal to the sum of the other two.
Okay. Teacher, I have a question.
Yep.
About like how do you get AC is equal to 6?
It's here. Yep. I'm going to show you. I actually do my triangle inequality in the red triangle. AC is greater than the difference of the other two, 10, 4, and lesser than the sum of the other two. So therefore, you have AC is greater than 6, lesser than 14. This is more like from a triangle's perspective, right? But if we can degrade our triangle into a segment, then you will be able to find out AC can indeed equals to 6. In that case, your triangle will be degraded into a segment. So far, so good?
Yeah, I think I got it.
Yeah, that's the triangles inequality, right? Let's say I have a triangle A, B, C. I'm going to have A plus B greater than C and A minus B lesser than C, right? This is the basic triangle inequality you guys learned from day 1. So far, so good? You see, this is a fairly easy problem. You're not using anything flowery, but as long as you understand the basic definition of inequality, you are good to go. All good? If all good, let's go for another problem. So the second problem is also a real application using the inequality. So the second problem is a problem that comes from 2003 AMC 10B, question number 6. Oh, number 16, excuse me, number 16. So again, I'll give you 1 minute, read a problem first. All right, so let's read the problem all together, okay? So the problem says a restaurant offers 3 desserts, okay, 3 desserts, and exactly twice as many appetizers as main courses, okay? Means the main course, if you have, let's say, M, the appetizer will be 2M, right? Twice of the appetizer and main courses. A dinner consists of an appetizer, a main course, and a dessert, of course. So what is the least number of main courses that a restaurant should offer so that a customer could have a different dinner each night in the year of 2003? Question is more like this, right? So basically you should have an appetizer, a main course, and a dessert, right? So the question says, how many desserts you have? 3 desserts. And how many main course, how many appetizer, how many desserts? You don't know, but you know that there are exactly twice. Oh, sorry, I think like there's a typo here. So the restaurant offers exactly 3 desserts. So 3 desserts is here, okay? And exactly twice as many appetizers as the main course. So let's say if main course is M, then appetizer will be 2M, right? Basically, you have 3 stuff. And the question says, how many main course the restaurant needs to offer to make sure a customer could have a different dinner each night in the year of 2003? In the year of 2003, there are 2003 year, how many nights? There are 365 nights, right? So that being said means the customer should have a combination between different appetizers, different main course, different desserts, put them together, make a different permutation, combination, whatever, and then you're gonna have at least more than 365 options, right? That's the only thing you can just basically do all the combinations every day in order to have pretty much every entire year can be covered. Okay, this is basically what the question is asking for you. So again, the most important thing is how can you construct the inequality first? How can I create the inequality for such a problem? I think this one is more conspicuous than the previous one, right? Previous one, you need to find out the triangle's inequality. But this one, who can tell me? How can I construct out the inequality? Yeah, you can always like type your answers into the group chat, or you can maybe unmute yourself. So it's a good back and forth, right? As long as you like to participate, so it will be very good for you.
Maybe we can total up the combinations of appetizer, main, and desserts and set it to greater or equal to the number of nights, because we need at least 365 unique combinations.
Is it right? I think that's very good approach, right? So in order to make it happen, you need to set up your appetizer first, and then set up your main course, and then set up your desserts, right? How many options for appetizer? 2M, right? How many options for your main courses? M. How many options for desserts? 3, right? If you multiply the 3 terms all together, you're going to be having the total combination of your desserts, appetizer, main course as a meal, right? So you want to make sure that one has no duplicate for the entire year 2003. So that being said means this guy should be more than 365. Is it right? 365. Very
Yes.
easy, right? Very easy, right? Nothing really flowery. It's very straightforward. All right. So what you're going to do is you just have to solve this inequality. This is nothing too complicated. It's going to be 6m squared greater or equal to 365. that part, m squared will be greater or equal to 60.83, blah, 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 blah. Then what are you going to do? What is the number if you make a perfect square greater or equal to 60, and you want to have that number as small as possible, right? The question says, should have at least number. Of course, m equals to 8. 8 squared equals to 64, right? That's the minimum number. I can make sure the entire expression is greater than 60.83, blah, blah, blah. See? Very understandable, right? So the correct answer for this is 8.
Teacher,
Mhm.
why don't we just like when we already got the formula, so 2m times m times 3, you need to equal or bigger than 365. Why don't we just just like use all the numbers and see which number will work? Because I usually do that. Like when I got the put in all the use all the like try all those options and see which one of the option will work.
Yeah, it's the same thing. Yes, that is correct. You can actually use the options A, B, C, D, E, put them back into the equation, right, to see which one works. Or you can do some more rigorous proof. So this is my solution is more like a rigorous process, right? Rigorous process. You do the calculation, you determine what is the lower bound of the m value. Of course, you can do the other way around. You can plug in all the values, right? Trials and errors, 4, 5, 6, 7, 8, and you'll be able to get an answer. But I think it really depends on the complexity. If the problem is super complicated, this is a very complicated expression, of course, I think it's easier to do the trials and errors. But if something, fairly easy, this is not a super complicated thing, right? And then you'll be able to see, you can actually give the derived process more rigorously. And also another very important thing I want to highlight is that this is for American math competition, right? AMC. This is more like A, B, C, D, E. But as long as you go to a higher grade, you want to go to the Canadian math competition, let's say for Euclid, the question really asks you to give the entire solution process. You can't just give some trial A, B, C, D, or like you give the numbers 1, 2, 3, 4. You have to give the super rigorous derivation process. So I think that's also a good opportunity. We can exercise and try the derivation process.
Okay, I understand that. Thank you.
Yeah, sure, no problem. Any question, just let me know. We have a lot of back and forth. Okay. So this is our question number 2, right? It's kind of like, I think still very understandable. Let's go to one relatively difficult problem. And let's try to see how we can create the inequality in a more complicated or like more flowery way. So this problem is a problem that comes from 2010 AMC 10B. Question number 17. Okay, read the problem first, 1 minute, and then we're gonna talk about it all together. All right, so let's have a look at the problem altogether, okay? The problem says every high school in the city of Euclid sent a team of 3 students to a math contest. A team has 3 students. So how many high schools? You just basically times 3, right? How many students? Each participant in the contest received a different score. Okay, so it means there's no ties, right? So everyone is like kind of like different. Okay, everyone has a different score. And Andrea's score was the median among all the students. Median, okay, means Andrea's score is in the middle. Median does not necessarily mean average. Okay, I'll finish the question first and then I'll answer the questions. Okay, so Andrea has a score. The score is the median, means there are many students in front of her, many students after her. She was pretty much right in the middle. So let's continue. And hers was the highest score on her team. Okay, so within her team, Andrea's score is the highest. Okay, but not necessarily for the entire team, for the entire like all the competition. Okay. Andrea's teammates, Beth and Carla, placed 37 and 64. Something like this. You have Andrea, right? You have Beth, you have Carla, right? Beth is 37th, and Carla is the 64th. Andrea is the highest. Of course, she will be smaller. She might be 36, maybe 35, right? I don't know. Okay. With all those information, the question asks you, how many schools are there in the city? Okay. So it looks like, so basically you have different schools, right? Each school, you can go for 3 students, right? Altogether, you're going to have like a bunch of students altogether. And then everyone has a different score. Okay, there's no even, there's no tie. Everyone is basically different. Okay, the ranking is very straightforward. And for this Andrea's team, because they have 3, right? He has another 2 friends. One is Beth, 37. One is Carla, 64. And Andrea's place is the highest, it's the best score in her team. And the question is, ask you, how many schools? Again, how can I use all the conditions given by the problem? Let's try to construct some inequality, and taking from there, hopefully we can solve the problem. Yeah, if you have any question, you can raise your questions for now. It should be between 32 and 37. So maybe I'm gonna ask Alex to give us some kind of information. You wanna have some elaboration?
I think it will be between 30, or Andrea's place will be between 32nd and 37th because it has to be less than Carl's place, which is 37, right?
Mm-hmm. Yeah,
and
yeah.
it has to be greater than 32 because hers was the median. And let's say if what's her name? Carla or something.
Carla, yeah.
Place last, then it has to be then since hers was a median, it has to be in the middle.
Yeah, I think that's a very good observation. I'm gonna write it down here, okay? So let's say she is like the ace, for instance, okay? So you said A must be kind of smaller than 37, greater than 33, right? Something like greater than 32, I mentioned. Perfect, that's a very good observation. Okay, what else? I see Yan, maybe you raise your hands, okay?
Yeah, I think we can actually find the Andrew's score, the first place, because every high school, let's say there's H high school. So there's going to be 3H students, right?
Yeah.
And when you divided them by 2, because Andrew is literally right in the middle, so when you divided 3h by 2, you are getting the middle number, which is the person in the middle who has it. So Andrew's place is going to equal to 3h divided by 2.
Yeah.
And then we can play the 3h divided by 2 into the a. So it's going to be 32. So it's going to be 3h divided by 2 is bigger than 32, but it's also smaller than 37.
Yep. Exactly. Yeah, that's pretty much the case. Exactly. I think Yan and Alex already give us a very big direction. So basically, as you can probably see that, let's say Andrea has the number 8th position, right? So just like Alex mentioned, this is my Andrea, right? Andrea is right in the middle. She's the median. So that being said, there will be A-1 people in front of her and A-1 people behind her. Is that right? This is the median, right? Because you're always going to start with 1, right? You cannot start with 0, right? You can always start 1, 2, 3, all the way to A. So there will be A-1 people right in front of her, higher score than her, and A-1 people behind her. So that being said, the total number of schools, like the total number of students will be what? A-1, the guys behind Andrea, plus 1 will be Andrea's position, and the A-1, the people behind Andrea. Does it make sense? These are the total number of your students. A-1 before, A-1 after, 1 in the middle, this is Andrea herself. So that one is going to be 2A-1. And bear in mind, how many students? Every school must give 3 students, right? Every school generate 3 students. So that being said, this number must be divisible by 3. Is it right? Every school, they go for 3 students. The total number of students, 2A-1. Of course, this guy is going to be divided by 3. So that being said, 2A-1 divided by 3, I'm going to say 3K. Is it right? 3K. So therefore, A will be what? 3K plus 1 divided by 2. 3K plus 1 divided by 2. 3K plus 1 divided by 2, because I just want to see how this A looks like, right? I'm going to do a very quick thing, right? This is not a magic, but I think you can basically figure out fairly quick. As long as I find out a number, let's say I'm going to go this way. As long as I find a value for A, I'm going to say, okay, is this A can be divisible by 2 when there's 3K plus 1, right? Or I can say, I'm going to basically find out the number for A, and then I'm going to verify if 2 times A must be a number divided by 3, and the remainder is 1, right? I think that one makes sense, right? I just want to say something like this. Now I'm kind of already got a direction. So my next step is I need to find out the value for A. What is my value for A? You need to find out the inequality to make it happen. So first thing first, Alex already helped us to figure out Andrea is the best student in her own team. And Beth already have 37. So of course, A must be lesser than 37, right? Andrea must be better than Beth. So she should be lesser than 37. How can I find out the lower bound? The lower bound is also, as Alex mentioned, because in total, there are how many students? In total, there are 2A minus 1 students in total, right? And also, they mentioned Carla. Carla ranks number 64. So that being said, the total student will be for sure greater or equal to 64. Carla might be the last one, but at least like 2a minus 1 should be greater than 64, which makes sense, right? So that being said, if you plug in here, you'll be able to find out a is lesser than 37, which is actually greater or equal to 32. 32. Which makes sense, right? So what we're gonna do is, again, like I said, sometimes when you have an inequality, what are you gonna do? If the a is positive integers, you can just enumerate them one by one, right? There are only 33, 34, 35, all the way to 36. There are only 4 options for a. Not too much options, right? Only 4 options for a. You just need to find out from 33 all the way to 36. You list out all the a's. Just try to see if you can find out a solution for this equation, because k must be an integer, right? You just basically try them one by one. This time you need to use the enumeration. Try them one by one. There's no way around. Try them one by one, you find out actually a is equal to 35. Only 35 can generate a positive integer for k. Besides all the other numbers, no way. Okay? Since you already have a is equal to 35, so the question asks you how many schools? How many schools? The schools will be this guy divided by 3, right? Your school will be 2a minus 1 divided by 3, which is in our case is 23. So that's the answer for our problem.
Okay, teacher.
Yep.
Why can't it be 33? Because I think 33 times wait, so,
If you type
so
30,
so let's say k is equal to 33. So 3k is going to be equal to 99 plus 1 is going to equal to 100. And 100 divided by 2 is going to equal to 50.
because a already has a range. A must be from 33 all the way to 36, right? You have 4 values for a. And let's say if a equals 33, 33 equals to 3k plus 1 divided by 2. Okay, that's what you mean, right?
Yeah.
So
Yeah.
66 equals to 3k plus 1. So therefore, 3k equals to 65. There's no way for you to find an integer for k. There's no integer for k.
Yeah, yeah. Oh, I got it. I got it.
Right? You got it?
Yeah,
The thing is, you need to.
I did it backwards. I saw like I misunderstood I saw they actually stood for K.
No. This is for A, right? Because check it out. A is here. We just find out the range for A. A is from 32 all the way to 37. That's going to be how you want to see the A.
Yeah.
Does it make sense? Okay, perfect.
Yes.
Yeah, any questions, just let me know. I'm here to help you guys out. Okay. Yeah, I think 3 problems is good enough, right? I already show you guys how to use this kind of like find an inequality, create an inequality, and you'll be able to solve the real problems. Okay, this is our category number 1. If all good, let's go to our category number 2. Let's try to see how we can use the inequality to do some calculation, right? To calculate some expressions value, so on and so forth. So let's go for our second category problems. Okay, the second problem we're looking at is a problem that comes from 2017 Cayley. Cayley is for grade 10, right? Our Waterloo exam, grade 10, question number 18. So the question says, yeah, again, I'll give you 30 seconds to read the problem. This one is easy, huh? Okay. The question is asking for the number of integers n for each 1/7 less or equal to 6/n less or equal to 1/4. So you need to find out how many n's in order to make sure this expression holds. Okay. N is an integer, right? So that's good. So you won't be able to have too many n's. But how can I basically find out the range of n? You're given such an expression. Of course, this expression is not easy for you to determine the value of n, right? But can you do some kind of quick modification, manipulation in order to make it more straightforward for our calculation? Okay, I see Galan have some ideas. I'm gonna ask Galan. Okay.
I think you can multiply both the numerator and the denominator of the two known numbers by 6. So you only have to compare the denominators because that will make all the numerators 6 and it will be easier to determine the values that way.
Is that right? That's a very smart. You see, at the very beginning, this kind of very difficult for you to determine, right? They're like kind of too far away. Is it possible I can do some kind of normalization? I make them the same numerator or the same denominator. At least I can do some kind of analysis. A very smart way is I'm going to times 6. 42, right? That's actually 1/7. 6/n, 6/24. Is that right? I didn't really change anything, right? Everything is the same. But as long as I find here, voila, the solution is already very conspicuous. I just have to compare the denominators. Is that right? So n will be greater than 24, lesser than 42. Is that right? So easy peasy, huh? Because the numerators are the same. I just have to compare the denominators. Okay? Student got a do you also have to time middle term by 6? No, you don't have to because the middle term already have 6. I times 6, but I didn't change the value. This guy is exactly 1/7. This guy is exactly 1/4. I just make the fraction number is not so, it's not like the, what should I say, like the most complete or like the most brief fraction number, right? I just make some kind of thing you can do a division between the numerator and denominator. That's it. You see, as long as you have this, you can directly do the comparison for the numerator, for the denominator. So therefore, n will be between 24 to 42. So easy, huh? How many n's in between? So 42 times 24, don't forget plus 1, right? From 1 to 3, there are 1, 2, 3, 3 numbers, not only 2 numbers. So many students got a little mistake here. They forgot to plus 1. So if that's the case, that's going to be 19. Is it easy? Understandable? That's for 19. You see, for our Canadian math competition, grade 10, question number 18, there's something very understandable, right? As long as you understand the basic concepts, the basic property of an inequality, you should absolutely have no problem to solve the question. So far, so good?
Yes. And the teacher, this question is actually asking you like, how many options can n be? I saw this question is asking you, like what is n? Like what's n's action number?
Can you say that one more time?
Okay.
Sorry, so I didn't follow too much.
First, I look at the question because I saw the number of integers n, for which the thing is, I thought this question is trying to is asking for us to get to figure out what n is. But it is actually asking the options for n.
Oh yes, because the question said the numbers of integer n for each blah 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 is, because like the numbers does not really mean the value of n, it means the options of n. Yeah, because you can have actually from 24 all the way to 42, there are 19 different n's can make sure such inequality hold. So the question is asked the number of integer n's, the candidates of n's to make sure the inequality holds. So that being said, that means, yeah, that's more like, yeah, like question is not asking for the value, but for the how many numbers, the total number of the values. Yeah, the total candidates. Yeah, sure. Okay, so all good? Good. Let's go for one relatively difficult problem. Okay, this is actually a problem from 2005 Chinese Junior Math League problem. So the question says, given A, B are positive integers, 56 is less or equal to A plus B, less or equal to 59. 0.9 is lesser than A over B, lesser than 0.91. Okay, with all those information, please determine the value of B squared minus A squared. Given A and B, they're both positive integers. I give you two relationships. A plus B is an integer, right? For sure, positive integer between 56 to 59. Not too much options, right? And A over B is actually lesser than 0.91, but greater than 0.9. Also very, very small, right? Very small range. With all those information, the question asks you to determine the value of B squared minus A squared. How do you think for such a problem? I'll give you guys maybe 1 minute. Think about it. Okay. So let's have some discussion. How can we deal with such a problem? So now you have two integers, right? You have A and B, and you have two inequalities. Basically, you need to determine the value for B squared minus A squared. Just forget about the inequality. Let me ask you another question. If this is not a problem for inequality, if this is an equation problem, if this is an equation problem, I give you one equation, A plus B equals to blah, 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 and then A over B equals to blah, blah, blah. And then the question asks you to determine what is B squared over A squared, something like this, right? Who can tell me? If this is an equation problem, then what should I do? What is the common approach to solve an equation? Maybe Galan?
I think we can first find the values of A and B, and then we can substitute it into our expression that we're supposed to evaluate.
Is that right? This is very understandable, right? Yeah, that's a very good solution. Of course, in order to solve this, basically you have two equations, you have two variables, right? At least you need to maybe cancel one variable, right? You can do some substitution, you can do some division, whatever you like, right? You need to cancel one variable, right? Using A to represent B, and then put A and B into the second one. Hopefully you get what you need, right? This is 100% understandable for an equation. Can we do something similar for the inequality? Inequality is not an equation for sure, right? However, I think they're very similar. For the equation's perspective, this is equation. Your goal is to cancel one variable, right? A, using A to represent the B, and then substitute it into the second equation. Hopefully you get what you need. Can we do something similar for the inequality? You also have two variables, right? Maybe you can do some magic to cancel one variable and find out a range of another variable. Because our variables are all positive integers, if you get a range, you can actually count them out, right? They can be 1, 2, 3, 4, 5, whatever. This is exactly the same strategy what we talk about from day one. So here's the million-dollar question. How can I use this to cancel the variable and then hopefully find out a range of what I need? Right? Equation, you cancel, everyone knows that. Inequality, how can you do the cancellation? This is something maybe you need to think about it, right? You know what? I'm going to show you one, and then you can tell me the other. Okay, I'm going to write it here. 56, A plus B, 59, right? The second one is here. The second one is here. I don't like to see B as the fraction, right? I'm going to multiple B on two sides of this inequality. So therefore, I can cancel out B, okay? I don't want to use like a fraction number. So if I times B, this is going to B, this is canceled, this is B, right? Which makes sense, right? I'm going to rewrite it here. And 0.9 B, 0.91 B. Okay, this is not a magic, right? I just basically do something. Now I need to cancel out like a variable. Hopefully I can do something. I'm going to show you something like this. Let's say, let's check out this part. 0.9 B is lesser than A, right? So that being said, as long as I add the B on the two sides of this inequality, my inequality still holds. Is it right? I just add B on the two sides of this inequality, nothing special. But don't forget, my a plus b is what? Lesser or equal to 59. So I'm going to drag it here. Is that right? My a plus b is less or equal to 59. So therefore, I'm going to be able to see this guy is lesser than 59. Why? Because this guy is lesser. This guy, even though it's lesser or equal, it doesn't matter, right? The equal cannot be passed on. You must have a lesser. Do you guys follow me for this part? Yes or no?
Yes.
Okay, the other students? Yeah, you can. Okay, perfect. Because as long as you have a lesser and lesser equal to, of course, you only have the lesser. The equal cannot be passed on. So that being said, you're gonna have what? 1.9 b is lesser than 59. So therefore, b will be lesser than 32. You see, this is not a magic, right? You're just basically using exactly the same strategy. You want to cancel out a variable. You cancel out a eventually, and then you got a relationship for b. b is lesser than 39. b is less than 39, which is a very good sign for b, but I need a range. Only less than 39, this is not going to work, right? I have to find out another part, the lower bound of my b. So I'm going to put it here. Who can tell me, using exactly the same strategy, who can help me do the second part of calculation to find out the upper range, like the lower range, excuse me, of b? I'll give you guys maybe one minute. You can do some calculation before you tell me how to think. Please, everyone, I'm already showing you what to do now, right? This is what I did for the upper part. Can you do exactly the same thing for the lower part and tell me how to find the lower part of b? You must learn from me. Okay, I see somebody already try to give the correct answer. Just give it maybe another 30 seconds. Or wait for the other students. So we like to make sure everyone have like an equal opportunity. You can participate, right? So don't be shy. If you got any question, any ideas, confusing, so on and so forth, let me know. I'll be able to help you out. All right, yes. So this time I'm gonna ask maybe Felix. I see Felix has the correct answer. Yeah.
So what I did first was I first find out the relationship of a plus b, and I first write a smaller than 0.91 b, and I add b on the both side. Then I can plug into the original equation, which can be equal to 56 smaller equal to a plus b smaller than 0.91 b plus b, and it can be simplified to 56 smaller than 1.1 b, and divide by 1.91 on the both side, and it will be equal to 29.31494 smaller than b.
Exactly right. That's exactly what we need. So I'm just going to highlight it. Pretty much the same thing, right? This part I'm going to use this. A is lesser than 91b. A plus b will be lesser than b plus 0.91b. And this part I'm going to use here. A plus b is greater or equal to 56. So therefore, you have 56 less 56 lesser than 1.91b. So b will be greater than 29. Okay, I ignore the decimal parts. Okay, b will be greater than 29. So that being said, b will be greater than 29, lesser than 32. So that being said, you don't have too much options for b, right? B can only be 30 or 31. 30 or 31. Okay, so, but is it possible that every time A is correct? So basically you'll be able to find out a value for A, right? Okay, you get a value for B. Okay, as long as you get a value for B, we need to determine the value for A, right? I need to have A, I need to have B together in order to find out my value for B squared minus A squared. How can I get a value for A? A is here, don't forget. A is here. A is between 0.9b and 0.91b. A is actually a very smaller range, right? So that one is easy because A is from 0.9b to 0.91b. So you'll be able to see if b equals to 30, then A is 27, A is from 27 to 28. It's a very small range. So therefore, the A does not exist. If b equals to 31, A will become 27 to 29. Yeah, that one is okay. A equals to 28. Yeah, right? You have to do some casework and then list out them one by one to find out what is the value for B. So that being said, of course, A will be equals to 28, B equals to 31. That's the only possible scenario for A and for B. So the question asks you to determine B squared minus A squared. You just plug in the value, is 177. See, that's the solution process. Okay, so this problem is not complicated, but this problem actually gives us a very important common sense. As long as you're dealing with multiple inequalities, 1, 2, 3, 4, 5, right? And then multiple variables for sure, you will be doing exactly the same thing as our equation. You need to cancel out one variable in order to find out a range of another variable. And taken from there, hopefully you'll be able to solve the problem. Okay, this is a very important approach. The approach is doing the cancellation for one variable and then derive everything into another variable. Right? So far, so good? Perfect. If all good, let's go for another problem. Okay? This problem might look like a little bit crazy, but trust me, as long as you understand the trick, this problem is very understandable. So this is a problem from 2006. Japan Junior Math Olympia problem. But this is an easy problem, not a crazy problem, trust me. So the problem says, given A is between 0 and 1, and a plus 1 over 30, I take a Gauss function. A plus 2 over 30, a Gauss function. All the way a plus 29 over 30, there are 29 terms, right? A Gauss function together equals to 18. So here, does everyone know the Gauss function? Can I have a quick survey? Do you know Gauss function? What does Gauss function mean? This guy means the largest integer lesser or equal to x. Can I have a quick survey? Does anyone know the Gauss function? This is a very common function. You're going to see that in your junior, in the AMC or in the Canadian. Okay, no problem. I'm going to give you a quick, the Gauss function is only a denotation. There's nothing flowery. Gauss function means the largest integer lesser or equal to x. I'll give an example. 3.1. 3.1 Gauss function means what is the largest integer lesser or equal to 3.1? What is that? Who can you post? Yeah, 3, right? The largest integer lesser or equal to 3.1. Of course, 3. What about 3.4? Also 3, right? What about 3.9? Okay, student says 4. No. A largest integer lesser or equal to 3.9 is still 3. Is that right? So that being said, it looks like as long as x is greater than 3, okay, because you know what? Like before this, I'm going to ask another thing. Then what about 4? What is the Gauss function of 4? 4, right? What about the Gauss function of 3? 3, right? So that being said, if you have an integer, the Gauss function of an integer is always itself, right? Because let's say, what is the largest integer lesser or equal to 4? Of course, 4, right? The largest integer lesser or equal to 4. 4 is equal to 4. Same thing, what is the largest integer lesser or equal to 3? It's going to be 3, which makes sense, right? So that being said, let's say as long as x is from 3 to 4, you can always have this equal to 3. Do you agree with me or not? Yes or no? Do you guys follow me? Do you guys follow me? Yes or no? Okay, the other students, yes or no?
I have a question.
Yeah.
So the name of this is the Gauss function. So like the mathematician guy, Gauss.
Yeah, Gauss function.
Okay, thank
Like
you.
the mathematician's name, the Gauss. Yeah, Gauss function. Or we can call it integer function. Or we call it floor function. You just have like so many names. They're essentially talking about the same thing. As long as you have a function and you have like a number between 3 to 4, right? You can hit 3, it doesn't matter. But you cannot hit 4. You can be very close to 4. But as long as you hit 4, you're going to put your Gauss function goes to 4. Right? I think there's something easy, right? This is not a crazy stuff. Okay, if we're all on the same page, let's try to continue. I'm not done yet. I'm going to drag the thing here. Oops. Okay, I cannot drag it. But anyway, yeah, so let me try to finish this. So my question says, look, I have a between 0 and 1. Okay, I want to do such a thing. A plus 1 over 30, I take a Gauss. A plus 2 over 30, I take a Gauss. Everyone is an integer, right? Because a is a positive integer, so this a is between 0 and 1. So these are things it's pretty much like a, you know, some like positive or non-negative at least, right? Everything together, all the way I add to 29 over 30. That guy equals to 18. Okay, that guy equals to 18. With all those information, the question asks you to determine what's the value for 10 Gauss A. 10A Gauss. 10A Gauss. Think about it. How are we going to deal with such a problem? So first of all, are we all good with the question? Like the question is understandable? Okay. So yeah, if you have any question, yes, vas-y. Hey, yeah, if you have any question, just.
I don't actually have any question. I just have like I think I have like some thoughts about this like question.
Yeah, sure.
Okay, so because because A is a positive number, right?
Yeah.
And one out of.
Yes, go ahead. Yes, I'm just trying to give a screenshot.
Like in this floor, in this floor thingy, I think like whatever A plus 2, I think it's still A because A is a positive number, and a positive number and point like plus 1 over 30 or 29 or 30 is during this process is still going to be A. So I think like 29A is equal to 18.
You said 29A equals to 18?
Yeah, I think.
Not quite, because I can give you like a negative example. You think, regardless, you want to add 3 over 30, you think that's going to be still A, right? If you take the Gauss. Yeah. Okay, I'll give you an example. Let's say A equals to 29 over 30. Okay.
Oh.
So A plus 3 over 30 will be 32 over 30. If you take Gauss, that one is going to give you 1, right?
Yeah.
But this guy, if you take Gauss, that's going to give you 0. Right? 0.5, right. You take a Gauss function is only 0 because the largest integer less or equal to 0.5 should be 0. So that's not quite. You say this guy plus whatever will be equals to A. Not quite. But that's a good try. Yeah, it's a good try though. There's no, so don't afraid of making mistakes. It's a learning process, right? No one is born to know. But let's take this opportunity to see how we're going to think for such a thing.
I think A must be 18 out of 18 out of 30 because when you remind me that, so some of them is going to be 0 plus 0 and some of them is going to be 1, but there's absolutely no way it's going to get to 2.
Yeah.
So this entire when you get it, it's all going to be 0 plus 1 plus 0 plus 1. So there's 18. Yeah. So there got to be 18 ones and other 11 zeros.
Is that right? I think that's a very nice approach. I don't know if you guys follow Yan. So here's the approach. I think he has a very good observation. So let's say I'm gonna repeat what he mentioned. Okay, a plus 1 over 30, a plus 2 over 30. That there's a Gauss, right? A plus 3 over 30, all the way a plus 29, 30, whatever, right? That one equals to 18. Because a is between 0 and 1. A cannot be too big, right? Let's say the biggest part you might even see is here, right? That's the biggest possible value. The biggest possible value, even though a equals to 1, that part is going to be 1, 29, 30. 1 and 29, 30, right? Even though a is 1, that one, the Gauss will only give you 1. You cannot have more than 1, right? So that being said, if the largest one after the Gauss is 1, so all the previous ones, there must be 1 or lesser than 1. Is that right? There's no way to have 2, 3, 4, 5 there, because the last one is 1, because like the previous one. Let's say if the a is very tiny, this one might be 0, right? So it looks like, because I'm adding 1 over 30, 2 over 30, 3 over gradually, this is going to be a bunch of 0, 0, 0, 0. And then at a certain point, it goes to 1. 1, 1, 1, 1, all the way to 1, right? That's it. And you're telling me the total answer is 18. For sure. It means what? Means how many in total? There are 29 terms in total, right? There are 29 terms in total, right? So that being said means what? The last 18 terms must be 1, while the first 11 terms must be 0. Is it right? Is this a magic? Sorry, so sorry, why the last term is 1 again? Yeah, no problem. I can give you an explanation one more time. So because a is between 0 and 1, right? A won't be too big. Even though I take a equals to 1, a won't be able to reach 1. Even though a reaches 1, the last term will be 1 and 29 over 30. 1 and 20i over 30, if I take a Gauss function, like I said, this is always going to be the largest integer lesser or equal than the number. So of course, 1 is the largest integer lesser or equal than 1, right? If the last one you can only get 1, then what about like the previous ones? There must be, they can be 1 or lesser than 1. There's no way to be 2, 3, 4, 5, and there's no way to be negative because a is positive. Everything is positive. So that being said, within this 29 term, the first 11 terms are all 0. The last 18 terms, it is 1. Which makes sense. Does it make sense? Does it make sense to you guys? All the other students, can I have some feedbacks? Are we all on the same page?
Yes.
Okay, perfect. But how are we going to do with that? The question asked me to determine the value for 10a Gauss. How can I use what I find here to determine 10a, right? My goal is to determine 10a. My goal is not to determine how many ones, how many zeros. How can I figure out? How can I? Yes, I'm gonna ask for Yan.
Okay. How do you figure out? Because let's see, because the first 11 terms is all 0. So it starts with the 12 terms. It's going to start to be 1. So it's going to be a plus 12 out of 30. So what a should be, like the only way a could make them to be 1 and not make them like so huge. So I think a need to be 18 out of 30. And after that, it's like 30. It only can grow bigger, but you can you can make it lesser. So then it won't get to 18. So I think a can only be 18 out of 30.
Yeah, I think that's a very close approach. Yeah, I think that's a very perfect approach. Okay, I don't know if you guys follow in. So let's think about it from here. Just like I mentioned, the 11th term will be what? A plus 11 over 30, right? This is your 11th term. That one, take a Gauss, goes to 0, right? So this is the 12th term. A plus 12 over 30, you take a Gauss, that one goes to 1, right? We're all on the same page. So that one actually means what? That one actually means A plus 11 over 30. This guy, I take a Gauss, goes to 0. Means this guy will be greater to 0, lesser than 1, right? Should be greater or equal to 0, but it really doesn't matter because A is greater than 0, right? That's not a big deal, right? But at least you know this guy should be lesser than 1. Does it make sense? Lesser than 1. However, whenever you go to here, that one give a Gauss, goes to 1. A plus 12 over 30 will be greater or equal to 1, lesser than 2. Is that right? If I have a Gauss greater or equal, I mean, if I Gauss equals to 1, by definition, means this guy will be greater or equal to 1, lesser than 2. Still remember? Here. If x is the Gauss of x equals to 3, means x can be equal to 3, no problem, but must be less than 4. This is exactly the same thing here. So that being said, you can actually find out 2 inequalities for A, right? The 11th term generates an inequality on the left. The 12th term generates an inequality on the right. Altogether, that's what you need. Does it make sense? Does it make sense? Yes or no? If you don't understand, I'll repeat it. That's not a big deal, yeah. But you need to let me know if you understand or not. Okay, perfect. I see many students say that makes sense. That's actually from the definition of Gauss function. It's the definition. So then you have to solve this inequality. That's it. The first one will be this guy, you solve it. The second one will be this guy, you solve it. So nevertheless, you're going to find out you solve this 2 inequality, you got a range for A. The question is ask you 10A, right? So basically you can find out 10A is actually greater or equal to 6, lesser than 19 over 3. That's actually where you get a value for 10A. That's not something complicated, right? You just times 10 on the 2 sides of here, times 10 on 2 sides of here, and then you consolidate these 2 inequalities, right? The 2 range together, you will get this. And there's only one integer within this range. A is actually equal to 6. 10A is actually equal to 6, right? The question asks you, what is the Gauss of this? This guy, go to 6. You see, the entire thinking process is fairly understandable, right? There's something too complicated. Yeah, so this is what we basically how to use the inequality to do some calculation, right? This is not something too crazy. It's only some calculation. The most important thing is you need to use the inequality to find out a range. Hopefully in the range, the A or the B is an integer, then you can find out all the integers within the range. So far, so good? Perfect. If all good, let's go to our third category. The third category, we're going to talk about how to use the inequality to do some guesstimation or evaluation, something like that. Something like that. So I'm going to have a problem that comes from (2002) AMC 10B, question number 7. It's an easy problem, so I'll let you guys read the problem first. All right, so let's read it together. Let n to be a positive integer such that 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 7 plus 1 over n is an integer. Okay, this weird expression is an integer. Okay, and which of the following statement is not true? 2 divides n, 3 divides n, 6 divides n, 7 divides n greater than 84, excuse me. Okay, so it looks like I won't be able to really find a value for n. It's more like a kind of a estimation. What does the n looks like, right? Okay, so let's have a quick look at it. I think the only condition I have is 1 over 2, 1 over 3, 1 over 7, 1 over n. N is a positive integer, right? That one goes to an integer. Okay. Well, who can tell me from such a condition, what can I get? Okay, I'm gonna ask maybe Yan.
Okay, what can I get? Because when you look at it, there's no, first I saw there's no way you can get like how the 2 divided by n. So first, I'm going to make all of them became like that. All their denominator became 42.
42, okay.
Yeah. So so it's going to be 21 out of 42 plus 14 out of 42 and 6 out of 42. And when I add 3 of them together, it's going to become 41 out of 42.
Okay.
And we know that any number is, no matter how big the n is, when they plus together, it's going to be an integer. So it's like 1, 2, 3, 4. So even n is equal to 1, they are still going to get 1 and 41 out of 42. So I'm going to, when they all add together, they're going to equal to so they are going to equal to 1. So because they're going to equal to 1, I can figure out what n is. So n is going to be 42, because only 1 out of 42 plus 41 out of 42 is going to become 1, an integer.
Is that right? I think Yan has a very clear proving process. Yeah, so for such a problem, don't be panic. Do a quick calculation. This is 41 over 42, right? Plus 1 over n. You want me this guy to be an integer. Think about it. N is a positive integer, right? N is a positive integer. you wanted this guy to be an integer. Is there like a lot of options, or there are not too much options? Let's go for this one. 41 over 42 plus 1 over n. This guy is for sure lesser than 41 over 42 plus 1, right? Because 1 over n is a fraction number. N is a positive integer, 1, 2, 3, 4, 5. So for sure, n will be lesser than 1, for sure, right? This guy is actually also lesser than 2. 1 and 41 over 42 is lesser than 2. So that being said, if you really want me to find an integer, 41 over 42, 1 over n must be equals to 1. No way around, must be equal to 1. There's no other alternatives, right? So if that's the case, then what's the value for n? N equals to 42. N equals to 42, what are the options? 42 is divisible by 2, by 3, by 4, by 6, by 7. It's not greater than 84. So therefore, the correct answer is, which one is not true, right? Not true is n greater than 84. You see, fairly easy peasy, right? We're not using anything flowery, complicated to make it happen. All right, so that's basically like question number, kind of like the first problem for the guesstimation. We're going to use 2 lectures talking about the inequality basics. We're going to give you more flowery, more interesting problems in our lecture number 2. And lecture number 3, we're going to go to the mean inequality. Okay, so no worries. So a quick summary, what we have learned in today's lecture. So we basically learned some basic inequality basics, right? All those kind of formulas we introduced at the very beginning. I think most of them are very easy peasy. There's nothing too flowery. We don't have to expand too much. And then we actually introduced 3 major type of problems for the inequality. The first one is trying to do some real applications, right? Some real problems in the everyday life. Find out the inequality and then solve it. The second one is try to determine the value of an expression. Like I said, most of the time, the inequality won't be able to give you the value. Instead, it wouldn't give you a range. But as long as the number is an integer, you can squeeze out, right? There are not too many integers between the range. So you can always do enumeration, list them out one by one, and then do some trials and errors to verify them one by one. Last one is basically we just get started. We actually teach you guys how to do some basic guesstimation, find out the range, find out the interval, so on and so forth. And in our next lecture, we're going to give you more complicated problems, more flowery problems, try to do the guesstimation, and some other interesting problems for the basic of the inequality. Yeah, I think that's pretty much what I want to say for today's lecture. You have any questions for me? All good? Okay, if you have any questions, you can always reach out to me from email or WeChat, whatever. And I'm gonna upload our assignment into our Google Classroom that you will be able to have access to. Yes, you go ahead.
Okay, and so I still don't understand what is polynomial.
A polynomial. Okay.
Yeah.
I can give you a quick thing. Yeah, polynomial. Do you understand this is ax plus b? Ax plus b. It's an expression, right? Have you noticed? Do you know this? Ax squared plus bx plus c. This is a quadratic, right? It's a quadratic.
Yes.
So these are all considered to be polynomial. Polynomial means any kind of expression I can write into an xn, an minus 1 xn minus 1, an minus 2 xn minus 2, a1x plus a0. Anything you can write into such a form, this is a polynomial. Of course, some terms can be 0, right? There's no need to have every single term. Some terms can be 0, but as long as you can write it into such a form, this will be defined as a polynomial, which will give you more ideas for our upcoming lectures.
Understand.
Okay, perfect.
And how do you access to the Google Classroom?
Okay, I can talk to you offline.
Okay.
Okay, I'll give you more information offline.
Thank
All right,
you.
so that's pretty much what I want to say for today's lecture. I wish you guys a good day, and I'll see you guys for the next week. I'll upload our assignment into our Google Classroom. All right, so thank you guys. Have a good one. Bye now.
You too.
Thank
Thank you.
you.
Bye.